Welcome back to Reverse Engineering with Capella. In this session, we're going to talk about developing the physical architecture for the smart robotic car that we've discussed using in the last couple sections. In this section, we're going to take a look at the physical architecture process, and then we're going to have some considerations we want to keep in mind as we're doing this architecture. We're going to capture a subset of the car with the physical architecture. We're going to use physical components and physical links as part of that process. And we're going to define the behavior of these components, then allocate the behavior to the physical components. We're going to define the functions of the behavior components, and then finally we're going to ensure that all this physical architecture delivers some sort of system capability. We are reverse engineering, so the system capabilities haven't really been captured yet. We'll probably be doing that in the next section, but we're going to walk through this, and then finally we're going to create some functional chains anticipation for these capabilities. Since we're doing a reverse engineering exercise, we're basically kind of starting with the physical architecture and showing how we can capture this type of system here with that physical architecture. We are still using, though, the same physical architecture process that we used with the Innovating with Capella first set of series. We're going to basically be walking through the operational capabilities that you're defining here for developing the physical architecture. We're going to basically then use these various functional chains to do that work. The big difference is that we're not going to be doing the transitioning because we're going to basically start with the physical architecture and go from there. Some consideration, you want to consider the model you're building kind of as requirements, so we don't go into too much detail. Again, we're working at the physical architecture and reverse engineering it out. We will be using some abstractions here because the mechanical design, electrical design tools, and electronics tools would actually have the lower level of detail. We're going to capture only what is needed, leave out what's not a constraint. So things like connector pins and things like that, we're not going to get into capturing in the physical model because we know that information would be captured in downstream tools that would actually have that information in it. We're going to consider that we are using different domains. So because of that, we are going to do some prefixing on interfaces so that we can figure out what interfaces are owned by what domains. But the main thing is, constraints are the primary drivers of architectural decisions. So if you introduce too many constraints, you overly constrain the solution space. So you don't give enough freedom to people that are actually doing the design. Okay, so first of all, we're going to start by refining and defining the actors and the physical components that we're going to have. And we're going to be focused on this blue flow right here, basically just essentially jumping right into the box that you're seeing here of defining the PC links. So this was the design that I've captured up to this point now. I'm going to show how this maps over. You can see some of the parts here in this diagram. The camera is right there. The camera module is this whole board that's on here. I'll bring up my screen. I'll bring up the device here. This is the actual, you can see right here, there's a board that has the camera on it. Then there's the camera module, which is that plastic board behind it. Likewise for the ultrasonic sensor, there's another plastic board behind it that holds that. And then here's the servo that basically is connected to it. And all these wires eventually connect into the I/O board that's located here. So you kind of see all those things in the diagram that you're seeing here. You're seeing the I/O board, ultrasonic sensor, and things like that. So you see those there. So let's jump over and we'll finish up this diagram a little bit actually in Capella. So I'm going to open up the physical architecture. I'm going to open up a camera and sensor diagram that you see here in front of you. And you can see in the diagram a couple of things of note is how to handle these nested components. The components don't have to be nested. So another way of looking at this is I could take this guy here and basically think of the camera is connected to the camera module. And then the camera module is connected down to the ultrasonic sensor, which is how it actually is mounted, mechanically. And I actually show these little prefixes with an M, basically the M prefix meaning it's a mechanical connection. So I have this mechanical connection from the camera to the camera module, and then the camera module has a mechanical connection down to here. Now, to show this nested, you want to still keep this link because there is a physical connection between the two, but it's a nested connection as opposed to kind of serially like it's shown here. So I'm going to basically just take this, drop it back inside, and then just rearrange that wire, the physical connection to be like that, so I still have that physical link on it. So just move this up a little bit, straighten out my lines to get them back the way it was. So that's kind of the first thing, is how do you do these nested components? You actually still have to make this link, because otherwise there's not something that you could reference requirements against unless you have that link there showing that mechanical connection. The other thing we'll look at here is we have more prefixes. I have an electrical connection here from the camera to the interface control board. This is a visual connection, so I actually have a prefix for the V for visual. Now the way I made this prefix is I used a constraint object, and I just brought in a table that I created in Excel and just dropped that table into this constraint object, and I used the standard trick of taking pictures and dropping them into it to make that happen. So very, very straightforward. Here's all the images that I have. That's how I basically did this too. I used a constraint object and dropped the image into it. So that's essentially how you do it. You can also assign images to other objects like this I/O board itself. For instance, I could just drop a picture right on top of it. Again, just using this set style to workplace image, and it would just navigate to a picture of the I/O board and drop it on it. You can see here I put the prefixes of E for these things here for electrical. These are all electrical connections with the I/O board. There actually is a physical connection too between this guy and this guy. So I could actually, in this case here, I could probably say E or M, EM as the prefix for it, because it actually is a mechanical connection also. So basically it does both mechanical and electrical. As you can see right here, one's a hat that sits on top of the actual control board. The physical connections then, so that's basically how you can do the kind of the physical connections for it. And let me see, anything else on this topic before I go on? Okay, so that's okay, so that's kind of that's how I got the physical diagrams done. I basically kind of mimicked the structure here. You can see that there's a servo, then there's a dead plate, and then there's a bottom plate. Here I showed them serially because they really aren't kind of encapsulating it. In a way, you could probably say that the bottom plate does include all these things if you wanted to, but in this case I decided to just keep it separate. Again, by having this link here, is I have something that I can anchor requirements with, or I can anchor parameters with, or properties with on the object. And what I mean by properties is I can do things like this here to add a property to it. I can navigate to the Project Explorer, something like that, and then I could essentially add a property to it. So let's say a string property, and I can add a string property to something to basically define what its requirement might be, or maybe some property around what its temperature range might be for handling it. Things like that could be assigned to it. So that's the type of thing that you could add as a property. Likewise, requirement objects could be dragged and dropped to it and connected to it also. So anyway, go to the next part. I'm going to just delete that from there. So the next thing I want to do then is start looking at the behavior components. So now when I'm working on the behavior components, what I've found the best to do is create a separate behavior component diagram. I like this approach better than to, let's say, dropping a behavior directly onto the physical elements. So because I could go over here, here's my behavior component menu. There's two types of adding a behavior component. You can deploy a behavior component directly to something. So I can just select it and just kind of drop it on the diagram. Or I can create it, and I'm just going to delete that permanently. Or I can create a separate behavior component diagram, and then once you have it created, you can just go and insert the behavior component on it. And that's the approach that I'm going to use for this. So let's go over and we'll create the behavior component diagram. So this is my behavior component diagram that I created. So I basically have the environment, and a lot of times when I'm doing this, I might keep the other view up in another window so I can kind of see the components for it. something like this. So I've got one for the camera. Let's grab. Okay, there's my other diagram. Okay. So I've got one for the camera, and I've got one for the controller down here, and I've got one for the ultrasonic sensor, and I got one for the servo. Now you notice I don't have one for everything. And the I/O board and the servo and dead plate and bottom plate, the module, I don't have any behavior components. This is an option that we have with working with Capella, is that we don't have to have behavior components for every object that's a physical component. And it's actually very helpful, keeps your diagram more simple. What you want to do with the behavior components is you want to do it for the things that are complex, that you don't understand, that you want to understand the functionality of, and developing out more of the functionality. If it's something that's well known and understood, it's okay to not have a behavior component for it because it's kind of understood what it's going to be. And an example being the I/O board. We'll use that kind of as a consistent example. An I/O board, everybody knows what it does. Functionally, it just maps, connections between one to the other, and that's a fairly obvious idea of what it does. So we don't really need to get into detailing out a lot. It almost is not any different than a wire. And we don't usually go into behaviors of wires. It just gets information from one place to the other. There's also other ideas, things like a router. If I was doing a design in the previous example with the solar charger, if there was a router that was being used for information going through a cloud system for measuring it, I wouldn't put that router into the model either, because I would just call it like the internet. So it just has the delivered functionality. I'd be focused more on the things that I'm going to be changing or in introducing it as a change to the system. So in any case, this is how I've kind of detailed it out. I did the same type of connections between the camera and the controller. You notice the directions here, we have component exchanges, and with component exchanges that are in this link here, there is a directionality to them. So you can, when you put them up, it'll actually draw a direction and put an order. There are two different types of ports. There are standard ports and flow ports, so you can select which one you want to use for those. And then there's the directions of each of those. So anyway, you can put all those things together. Inside of these, then, I have basically the linkages between them. So I show the servo going to the ultrasonic sensor. I also show the servo going all the way to the camera, because it does rotate the camera. It rotates the camera because of a mechanical connection that's being made through the path. But again, the idea is I don't also want to limit too much how things how it could be implemented to carry it. So I'm basically focusing here just on the fact that I need to have some type of relationship between the servo and the camera, because I want to be able to connect it. So now once this is created, so I've defined the physical component, the behavior components, and basically now I'm in kind of this flow here. I'm doing the orange flow here. I want to basically take those, I define them, now I want to basically assign them to the physical nodes. I can go and do that. And with this approach, I'm basically going to take these behavior components and drop them onto the diagram. And when I do that, the diagram starts looking like this, where now I have the camera and the ultrasonic sensor, the servo, and the controller basically now been assigned to those physical objects. And I'll show you how that's done. So I've got this view right here, and in this view, I'm going to close this one out. Okay, here's my camera, and I'll look at the semantic browser, and I see I do have a camera object deployed to it. What I'm going to do right now is I'm going to basically, I'll go ahead and add this to it. Now, since it's been deployed, I can basically just go to the behavior component object that we have here and say deployed PCs, and just draw the object on, and there you see the camera object will basically show up and be located to it. Now let's say I didn't have, this was not deployed at all. I'm going to using the manage behavior component deployments, clicking on that. So I'm going to undeploy it. If I undeploy it, So now there, you notice here in the semantic browser that camera isn't allocated anymore to that physical component. The behavior hasn't been allocated, and there's not referenced here. To make that deployment, I would again go to Manage Behavior, PC Deployments, click on it, and then now you'll see ones that are available to be deployed. And I'll basically say, okay, I want that to be deployed to it, and I'll get the object back on there, and then I just have to reposition and put it on. Now, so I did that for the camera, and I'll do the same thing then for the I/O board, and see me adding the I/O board, or actually the controller for it. So there's a controller, it's already been deployed. So taking a look at what that all looks like, I've got a diagram created with it all deployed. This is essentially what it would look like. I got to put this back in the right position. Okay, there it goes. And there's the camera object, and there's its behavior component. And here we go. So this is all the objects now have been deployed onto the diagram. And I'll clean it up a little bit. And so here's the physical behavior component board. This is the, so now I've made, you'll start seeing that, okay, I have this link here that's going between this guy and this guy. This is the physical links. And then here's the component object, the component exchange that we got from the behavior component object. Just move things around, make it a little neater. Okay, there we go. So the camera, so I've got this, this goes from the controller, or from the camera to the controller board, is that behavior component, component exchange. And then I've got this physical link. Now, in this case here, what you always want to do with these physical links is you basically want to make sure the physical link has a component. If I open the physical link up, you'll see that there's a component exchange allocation that's been done. So I have a component exchange is allocated to this physical link, and you'll see it populated right there. It's taken care of. And when you do that population, you create these little lines start showing up, showing that the component exchange has been allocated to that physical link. So you see that that's been done. Over here, I don't have that done yet. So how would you do it though when you have a physical link that basically goes to these I/O controller board, then goes to the controller board itself? So what I'm going to do is take off a couple more. And how you have to do that is with these things called pathways. I've got a couple pathways already created here. I'm going to go ahead and take them off for the time being. I can take them off by going to this little caret that's over here on physical links, and you'll see these things called physical paths. I'm going to take the two physical paths that I've created already. I'm going to take them off. So you can see here that I have this. I want to go from here all the way to this controller board. I want to create now something called a physical path that will connect the two. Now, creating the physical paths are very similar to creating functional chains. It's really very easy to do. Is I can just sit on the object here and sit on this interface, and then go and select another interface here and say physical path. And in this case, I'm going to create a physical path, and it's going to be from the camera to the controller. So I've created now a physical path object, and you can see it's color coded to the color blue. You can change the color codes by changing the properties on the objects and change them that way. But there's the pathway for it. So now once I have the pathway created, I can then allocate to the pathway, instead of to the interface itself, the component exchange. So then here's the component exchange that's relevant, and it will only pick the objects that are relevant. So now I have the pathway created, and you can see this little link showed up here showing that it is it has that connection to it. Move this out of the side so you can see that there's the connection there, and down here you'll see that there's a connection now, a little allocation that's being done here for it. So that's how I made that camera the controller board. I'll go ahead and add the other pathways back on that I've created, and I'll have to create a few more. Physical paths, I'll add those on. So created physical paths then for this guy, for going from the servo through the I/O board to the controller board. So I've got one for that path. I've got one here from the ultrasonic sensor to the I/O board to the controller. I've got that one, so that's this one here. I've got a couple more that I've got to do, and I will do those. One here, it's more of a mechanical one, is that for, let's say this one here, I got to go all the way from the servo to the camera. So to do that, I'm going to select this flow. Again, select the interface, hold down the control key, and I'll get that interface. And then I got to go from there to the servo. So I've got a whole connection path there for those, and I create a pathway for that. Here's the physical pathway. For this one here, I'll even label that pathway as a mechanical pathway, so I'll put a little M in front of it. And I'll say that's going from servo to camera. Yep, that's servo to camera. Now once that pathway is created from mechanical from servo to camera, I'll double click on it and I'll assign the component exchange to it. And that component now exchange is now allocated to it. So there's the component exchange that's been connected to it. And we have that whole pathway cover. The last one to do would be from this one right here. It's for this one. So I've got to go from servo to the ultrasonic sensor. To do that, I have this mechanical link here that it has to go through. And so I think in that case, I think I'm covered. I just have to, oh yeah, I'd have to go this mechanical link and that mechanical link. So I've got to select that one and then this one here and create the pathway for it. And there's the pathway for that physical path, which is a yellow one, which is a little harder to see. And since it's yellow, let's see if I can change the color of it. We'll go with orange, might be a little easier to see. And do an update. Yep, so I was able to change the color of it. See, there's the orange color there. And I'm going to call that one then servo to USS. And again, I'll label it with I'll put an M prefix just to show that it's kind of a mechanical link. This cam to controller, F2, I'm going to make that, yeah, it's a wire, so it's going to be electrical. It could have some it does have some mechanical purposes to it because it goes through the I/O controller board. So this one is a little bit of both. It has some mechanical and electrical aspects to it. So I'll just do an ME. The controller to the USB. Again, that one's going to be mainly mechanical and it's going to be a little bit of mechanical and electrical. And controller to servo. That's going to be mainly just electrical. Just to kind of highlight things. So that kind of shows all my connections then and how I've done it. Now you can understand how this is a lot messier, a lot more busy, but it still serves a purpose, especially when you want to see how everything's kind of related and connected together. And I'll show you later actually maybe putting on here even one functional chain for it to kind of show the whole connection and thread through the system. Okay, so now going on to the next part. The next thing we want to do is actually add some functionality. So we want to allocate physical functions interactions to the behavior component. So to do that, we're basically just going to add functions then to the object. So in this case here, I've added functions to transform the light to the signals, receive the position, receive video signal, determine distance, set position, and send a ping, receive a reflection, receive position. Those are all been allocated to these various items that we have here. If I open up the model, we can see those behavior components and the physical objects connected to them. So I've added them on, and that shows kind of that they're connected to. And then what the functionality is. Now I've added the functionality. The functionality though is still, it gets a little cluttered because I don't know, the controller is doing multiple things, and it would be nice if I could group them into some type of distinguished capability. And that's really where then the next step of the functional chain comes into play, is I'm going to basically do some groupings of these objects. So I'm going to basically kind of ensure that this is a step in the workflow I've done previously of ensuring the physical architecture delivers the system capability. So I'm going to basically define system capabilities, which are basically the functional chains. So the camera function I basically have defined as this functional chain here. The USS function is this determine the distance that's going through here, and then the servo function that we're having here for setting the position. And then I could and I can go and add that in. I actually have a functional chain diagram here for it. There's the functional chain, and I can change this. This could be, instead of camera function, I could say video, receive video. Might be the capability for it that I would be talking about with this, receive video. And so there would, essentially, you would want to have a system capability that was around receiving video. This would be sense distance would be the functionality that we're getting out of this one. And then the functionality here would be rotate camera. And be that green flow there. So you can see I'm rotating the position of it. And in this case, I don't have a complete rotate camera. So I got the servo, I got the set position, I'm turning the servo, but then the servo is actually can go and basically modify these positions. So I'm going to just go in and tweak that functional chain a little bit. So I'm going to open up the functional chain. There's position, and I'm just going to add a couple more links to it. There's the receive position for that one, and then receive position for him, for that one there too. I'm going to lay out the range all to lay things out, make it look a little better, and go back to the view we had here. And you can see here the rotate camera and ultrasonic sensor is all being done on this green flow. So basically I'm setting the position is going to the servo then is impacting these things. So this kind of shows then the connectivity between a capability that I'm going to eventually be addressing and connecting it up to this physical part of the system and all the things that it kind of does. I didn't get into connectors or pins or anything in this. Again, I'm trying to not overly constrain as I'm capturing the physical architecture. I'm just basically capturing the functionality that these things are doing. So I'm trying to still keep things at a fairly high level as I'm doing this. Okay, next, going further, so basically now I'm completed kind of everything I wanted to cover. And then the last thing I might want to do is actually take some of this functionality and put it back onto one of these behavior component diagrams. So what I'm going to do is I'm going to take this diagram here and clone it. And delete that one. Rename. Okay, and I'm going to say this was camera. So I have the camera functionality that I'm going to be worried about. So I'm going to open that one up, and I'll basically bring on the functionality for the camera functionality. Moving this over a little bit there. I'm going to drop it onto the functional component here. Okay, transform light to signal. It's been dropped on that one. Okay, so there's the camera. I'm going to add into allocated function here, provide obstacles, and I'm going to add functionality then to the controller board related to the camera, receive video signals. So this might be then, and then last thing I can do is bring on the functional chains to show the whole chain of functionality as it's going across it. See video, and there it is. That's the chain of functionality for this object. So And now it's been overlaid on the diagram. So that might be the diagram that you might show to show how the functionality is mapped across it. Anyway, that's all I have for the diagram. I'm going to post this up to the YouTube channel. And you can find it up there on Tacomar OSP, Smart Robotic Car. You can get a copy of it. You'll find, and to basically get to that, you would just import onto your project. So let me just close things up here a little bit. If you want to do import, and then projects from Git, and clone the URI, and just plug in that path name that I gave you into this link, and go ahead and download it. You don't need the username and password because it's an open project. And when you do that, it'll basically give you a link for the master branch. You want to pull down the master branch. And that's it. That's how you basically get it. Just going back and reviewing and summarizing then what we covered. We talked about some considerations when we were reverse engineering. We captured a subset of the car, the physical architecture and node components, physical links, nested components, showed how to handle those. We authored some behavior components. We allocated behavior components to physical components. We used physical pathways over simple and well-understood components. We allocated the physical architecture to the behavior components, and we created some functional chains for anticipated capabilities. So thank you. I hope you enjoyed the session.